Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today we are going to discuss the topic on the discussion of tutorial question bank, the module 3. The topic name is functions of several variables. Before going to discuss the question bank like module 3, first of all, we need to discuss about that the chapter, the topics, and again based upon the topics what we are covered, and again what we are going to discuss that clearly. And after that, clearly we are going to discuss the question bank, particularly under this module 3, that is the functions of several variables. Here, the module 3 functions of single and several variable. Under here, we are going to covering the topics like mean value theorems. That under the mean value theorems, that is a Rolle's theorem, Lagrange's theorem, Cauchy's mean value theorem, that particularly we are going to discuss that without any proofs. And again, whereas the second one, that is the functions of several variable, under here we are going to covering the topics like partial differentiation, and based upon the partial differentiation, here that clearly one by one, that is the topics like Jacobian functions dependence and maxima and minima of functions of with 2 variables and 3 variables, and finally method of Lagrange's multipliers. These are the particularly topics under these are the like module 3, that is the functions of several variable. First of all, under here module 3, we are going to divide like that particularly like a part A and part B likewise. Here whereas the part A, that is based upon the single and several variable. Under here, that is a covering, that is a mean value theorems. One is a mean value theorem, is a Rolle's theorem, and second one is a Lagrange's mean value theorem, and again the finally it is a Cauchy's mean value theorem. And before that, here we will go to discuss that what are the formulas, like what are the conditions for the mean value theorem. First one, that is a Rolle's theorem and Lagrange's theorem and Cauchy's mean value theorem. And first it is a Rolle's theorem. And under here Rolle's theorem, what are the statements, and again it is based upon the statements under here what are the conditions it is involving. And based upon that, here we will go to discuss that one by one the continuation. Here the Rolle's theorem. While we are going to discuss the Rolle's theorem, it is clearly let f is a function, that is f of x is be a function such that it is first is satisfied the continuous function in the closed interval a comma b. Second one, it is a differentiable in the open interval a comma b. And third one, based upon this one, f of a is equal to f of b. That means these are the 3 conditions are required to satisfied. Then only the function is said to be like Rolle's theorem, it is satisfied. That means any given function it is satisfied in the closed interval given like a comma b. And again the differentiable is also existed, that is under the open interval a comma b. And again f of a is equal to f of b. If it is 3 conditions are satisfied, then there exists at least one point, that is at least one point C in the a comma b, that is open interval, such that f dash of c is equal to 0. This is the clearly that under the Rolle's theorem, that is the first mean value theorem. That means f is a continuous function in the closed interval, and second one it is a differentiable in the open interval, and again the third one f of a is equal to f of b. Then there exists such that that is a f dash of c is equal to 0. Then there exists c belongs to a comma b. Here these are the we need to remember while we are going to discuss the question bank, and again at the time of the problems. And again the second one, what is that here, that is a Lagrange's theorem. The Lagrange's theorem is also nothing but let f of x be a function such that it is also f of x be a like a continuous function, same like that. First one, it is a closed interval a comma b, and second one, it is also differentiable in the open interval a comma b, and then there exists at least one point, that is a c in a comma b, here such that f dash of c is equal to f of b minus f of a by b minus a. These are the 2 conditions are required to satisfied under the Lagrange's mean value theorem. That means one is a continuous function in the closed interval a comma b, and second one is a differentiable in the open interval a comma b, and then there exists at least one point, that is a c in a comma b, such that f dash of c is equal to f of b minus f of a by b minus a is the conditions. Here, these are the three conditions required to satisfied according to the Lagrange's theorem. We need to verify at the time of the problems. And here, the third one, it is a Lagrange's mean value theorem. And again, we need to recall what is a Lagrange's mean value theorem. Here also, where we are observing that first rules and Lagrange's, only the two conditions are required, like only one function it is involving. But whereas a conscious mean value theorem, by the observing the problem like that anything, without giving that statement like that conditions, easy to identify the functions are involving like the two functions. One is a f comma z, that is f is a function and g is a function that belongs to R, that is nothing but f of x comma f of g are both are the functions are the continuous functions. And again, it is a f comma g are continuous in the closed interval a comma b. And moreover, that is f comma g are the both are the differentiable, like in the differentiable in the open interval a comma b. Then there exists, that is provided here, g dash of x is not equal to 0. Here, then there exists like g dash of x is not equal to 0 for all values of x belongs to a comma b, such that that is a condition at least one point here also c in the a comma b, such that it is a f dash of c by g dash of c is equal to f of b minus f of a by g of b minus c of a. And these are the two conditions are required, and moreover provided g dash of x is not equal to 0 for all values of x belongs to a comma b. Then there exists only, it is a condition is at least one point, that is c belongs to a comma b, such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Here, why it is g dash of x is not equal to 0? Because of, if it is g dash of x is equal to 0, that means g dash of c is also it is required to satisfy not equal to 0. In case g dash of c is equal to 0, then automatically the denominator it will be, that is infinite value. Based upon the condition, here compulsory provided it is a condition is g dash of x is not equal to 0. Due to that reason, it is a g dash of x is not equal to 0. Then there exists here the condition at least one point c belongs to a comma b, such that f dash of c by g dash of c by f of is equal to f of b minus f of a by g of b minus g of a. And based upon these are the three theorems, next we need to continue, that is like a continuation at the time of the question bank. These are under the part A, that three mean value theorems. One is the rules, second one is the Lagrange's, third one is a Cauchy's mean value theorem. Under the Cauchy's only the two functions, the rules and Lagrange's are the only one function it is involving. And further we'll go to discuss that is a part B also. What is a part B under these are the topics. While we are going to observing the part B under the functions of several variable like that single and two variables, that is the first part is a mean value theorem, and second one is based upon the partial derivatives. That is starting with the partial derivatives. Here, the first is the partial derivatives, and again second one is based upon the Jacobian functions, and again that continuation, that is the functions dependence, and again further to finding the maxima and minima of functions with the two variables and also the three variables. Under these are the like the single and double and triple variables. These are the particularly we are going to discuss that. Finally, it is a Lagrange's multipliers method. This is also nothing but to finding that based upon the maxima and minima to finding the solutions. These are the covered like part B, and further we'll go to discuss that one by one again under part B, like what are the regarding the partial derivatives and again the Jacobian and functional dependence and maximum minimum. Little bit the concept we will go to discuss, and based upon that easy to discuss the like question bank also. Here, what is a partial differentiation? How to define? What are the conditions under the first derivative and also the second derivative? First, just we'll give that some introduction like formulas how to find the solutions. And again here, let f is a function. Whatever the function under the x comma y is the two variables. Here the dependent is nothing but it is x comma y. Like dependent is f, and again independent variables are x comma y. And based upon this one, it is for example first derivative. The first derivative means it is nothing but with respect to x comma y. That means f is any function with derivative with respect to dou by dou x, that is dou by dou y by dou x. That is the first derivative with respect to x only. And again similarly derivative with respect to y. And again here also with respect to y is nothing but you obtain that dou y by dou y. That means the dou y by dou x and dou y by dou y both are the first derivative. And again next one on the dou by dou by x. Again we need to derivative with respect to x one more. that is a dou square a by dou x square. That means second time derivative. That is a second order derivative. And again, similarly, same on the dou by dou x with respect to dou by dou y. That means again the second time derivative on the dou by dou x. That is a dou square a by dou y dou x. These are the second order. And similarly, whatever we obtain the dou by dou y, again with respect to dou by dou x, we obtain that dou square a by dou x dou y. And further, we need to derivative with respect to y also. That is dou by dou y with respect to dou by dou y. That means dou square a by dou y square. These are the first order is nothing but dou by dou x and dou by dou y. Second order is nothing but dou square by dou x square, dou square by dou x dou y, dou square by dou y dou x, and dou square by dou y square. These are under the first and second order partial derivative. And first one it is a first order and second this is also first order. And again further whatever it is a right side second order is a dou square by dou x square and dou square by dou x dou y, and again further dou square by dou y square. The left sides are the first derivative is a first order and second derivative is a second order. And sometimes it is nothing but that is a pu and it is nothing but q, and again it is nothing but r and it is nothing but s, and it is nothing but the t is the value. And in other some books or something authors are mentioned that p is p and q is q and r is nothing but l, and again s is nothing but m, and t is nothing but that is a n. But these are the standard forms like first and second order with respect to x and y corresponding on the given functions. This is the clear review of the partial derivatives with respect to x and y under the first and second order. And further here while we are going to discuss this is a according to function is a continuous, it is automatically both are the same. That is the second order dou square by dou x dou y is equal to dou square by dou y square. And further that is a Jacobian. That means based upon the partial derivatives, that is a further it is a Jacobian. And what is the meaning of Jacobian? And again that is nothing but based upon the dependent, based upon the independent, under the two variables and also three variables. We'll go to discuss that is a partial derivatives. Here Jacobian, let u comma v are the functions of x comma y. That is nothing but the independent variables are x comma y. The dependent is nothing but numerator, that is u comma v, and again the independent is nothing but that is x comma y is the variables. That means here u comma v is the dependent and x comma y is the independent variables x comma y. And based upon this one, the Jacobian of u comma v with respect to x comma y, and it is denoted by that is j of u comma v by x comma y is equal to dou of u comma v by dou of x comma y is equal to, in the determinant formation, first one with respect to u to ux, u to uy, and v to vx and v to vy. That means the numerator corresponding like that ux uy and again vx vy. That means u2 that is ux and again vy, and again second is a v that is a x and again vy. That means ux uy and vx vy, that with respect to dependent and independent variables. And again further it is a similarly under the three variables are also u comma v, and again v is a function and w is also function. That means u comma v comma w are the dependent and independent variables are that is a x comma y comma z. And based upon here also the three dependent, three independent is nothing but that is also clearly the 3 by 3 condition. That means here also same like that dou of that is j of u comma v comma w by x comma y comma z is equal to dou of u comma v comma w by dou of x comma y comma z is equal to that is 3 by 3 determinant process ux uy, here ux uy uz, and again similarly vx vy second is also vx vy vz, and w is also wx wy wz. It means here also same like that u2 ux uy, that is ux uy zz, and second one is also vx vy and vx vy vz, and w is also wx wy wz. These are the clearly according to with respect to that is a 3 by 3. And similarly in any number of variables are also like with respect to dependent and independent variables, we define these are the clearly the Jacobian functions with respect to like depend upon the independent variables. These are the we need to recall that is under the two variables and also the three variables. This is the based upon the partial derivatives that occurs. And further the properties of the Jacobian. And based upon the properties of the Jacobian here, that one is j is equal to, for example, dou of u comma y by dou of x comma y, and j dash is nothing but that is a reciprocal, that is a reverse of that is nothing but x comma y by u comma v. And again, then with the help of this one, that main condition is j into j dash is equal to 1. Here it is always conditional. And second one, if u comma v are functions of, it is a u comma v are functions of x comma y, like u comma v are functions of r comma s. That means here it is a u comma v are the dependent, r comma s is the independent. That means it is a u comma v, that is a, it is r and s, and v is also r and s. And again, similarly, r comma s are functions of x comma y. That means r is also function of x comma y, and s is also function of, that is x comma y. And based upon here also we need to consider the dependent is a numerator and the independent is a denominator. First one is dou of u comma v by dou of r comma s, and r comma s is also function of x comma y. With the help of this, it is a condition is satisfied dou of u comma v by dou of x comma y. This is clearly nothing but it is indirectly, it is a composite function, we need to assume that. And again, the third one, it is if u comma v are two functions of x comma y, then the function is said to be, that is a dependent. As we know that the meaning of the dependent, that is nothing but indirectly it is a linearly dependent. As we know that the linearly dependent and also the functionally dependent, like related to the terminology, that as always the dependent is nothing but the det is equal to 0. That is det is equal to, that is a 0. Det of a is equal to 0. And here also, based upon this is also condition is, it is a dou of u comma v by dou of x comma y is equal to also, the term is a 0 conditions. And similarly, under the three variables also, the functions are like u comma v comma w, the independent variables are x comma y comma z, and it is also nothing but the dependent is nothing but the det of that a is equal to 0, that is nothing but linearly dependent conditions. And whenever the det is, for example, not equal to 0, that means the function is said to be linearly independent. These are the major properties under the Jacobian. The first is j into j dash is equal to 1, and second one is the dou of u comma v by dou of x comma y is equal to dou of u comma v by dou of r comma s, and dou of r comma s by dou of x comma y is the conditions. And further, that linearly dependent, that is a dou of u comma v by dou of x comma y is equal to 0. And last one, it is a dou of u comma v comma w by dou of x comma y comma z by, that is a dou of u v w by dou of x comma y comma z is equal to 0. These are the, like under the two variables, and this is the under the three variables. These are the properties we need to remember while we are going to discuss that question bank, and these are the module also. And further, one other important property is other than this the composite, and again other than this the linear dependent, and also j into j dash, that is a implicit formula. The implicit is nothing but whenever the function is not possible to separate the independent and dependent, that is called as a implicit function. At the time of the implicit function, then how to find the solutions? That is nothing but here also, if u comma v are, if functions of u v w are in x comma y comma z, then that is treated as, first of all, that is f1 of u v w comma x y z is equal to 0. That means the function is not possible to separate. Implicit is nothing but not possible to yeah, this is the important to understand. Whenever the function is not possible to separate the variables, at that time we need to follow with the help of the implicit formula. At that time, that is treated as a given equation is like that f is a function of, that is u v w comma x y z is equal to 0. And similarly, other function is also considered the equation f2 of u v w comma x y z is equal to 0, and third one, that is f3 of u v w comma x y comma z is equal to 0. And based upon the three functions here, while we are going to finding that under the three variables, that is dou of u comma v comma w by dou of x comma y comma z is equal to, and again here also whatever, either it is remember, and again it is remember, if it is followed like with the help of the dou of u comma y comma w by dou of x comma y comma z is equal to, we need to remember here how many variables here, that is a three variables, nothing but it is a three functions. It means it is a three functions. Three functions is nothing but it is a minus 1 whole cube. it is a minus 1 whole cube. And again, similarly, in this function, it is a, here also either remember two functions. That means whenever the function is like that, u comma v is nothing but the two functions, and again uvw is nothing but that is the three functions. And in that first one, that u comma v comma w is a three function is nothing but we need to remember minus 1 whole cube. That is a, it is a three function is nothing but in the given equation it is a three function is a minus 1 whole cube. And again similarly that functions are f1, f2, f3 is nothing but these are the f1, f2 is nothing but f1, f2 and f3 by x comma y comma z. This x comma y comma z, we need to assume that the denominator of the denominator whatever it is that you put in the numerator dou of x comma y comma z, and rest of the values that whatever the numerator it is there that you need to put in that u comma v comma w by in that denominator, that is dou of u comma v comma w. And based upon this assumption, based upon this remember, then easy to find out whatever the given equation under the dou of u comma v comma w by dou of x comma y comma z. And here if it is understanding like that the other side is also like the dou of u comma y comma w by dou of u comma y comma w is nothing but, and here also that is a three functions, therefore that is a minus 1 whole cube. And again the next one that the functions are like f1, f2, f3 that you put in that f1, f2, f3, but denominator it is uvw that you put in the numerator of the uvw, and numerator xyz that you put in the denominator xyz. And again it is a three functions, it is a three function is nothing but these are the three function is nothing but minus 1 whole cube. And similarly under the two variables are also the dou of u comma v by dou of x comma y, that means it is a minus 1 whole square because of it is a two functions only that you put in the numerator, it is a two functions. And again here also the two functions are nothing but f1 comma f2, and again here x comma y is nothing but you put in the numerator the denominator, and again u comma v is nothing but the denominator u comma v. And again similarly the right side is also dou of x comma y by dou of u comma v is nothing but minus 1 whole square into that is a like dou of f1 f2 by dou of u comma v by dou of f1 f2 by that is the dou of x comma y. These are the important formulas we need to remember according to under the like functions of several variables that is under the particularly the Jacobian based upon the implicit formula. We need to remember like this. Yeah, and further based upon this one here the like maxima and minima of functions of like with the two variables and also the three variables. And here also we need to understand here what are the conditions it is required to satisfy, and again how to find the solution, what is the working rule under this the maxima and minima. And after that we need to discuss that continuation of that whatever it is a question bank under this is the important today class. And again here we need to remember what is extreme values, and again the stationary values or turning values, and also the saddle point. These are the 3 points we need to remember while we are going to discuss that is a like maxima and minima. And first one is a extreme values. The extreme values is nothing but it is called as a like turning values are maxima or minima. Like the extreme values is nothing but it is called as a like extreme maxima or minima values are also known as a that is extreme values. And next one is stationary values or turning values. This how to find that? What is the meaning of this one? That means whatever the first order derivative with respect to x and y, and again by solving that first order derivative equating to 0, by solving that first and second order like first order that is with respect to x and y is equal to 0, while we are solving that particular two equations we get the values. That values are called it is a stationary values. And further it is a what is a saddle point. Saddle point is nothing but whenever the function is said to be neither the maxima nor minima of a function is said to be it is a saddle point. And these are the three main points we need to remember in our mind while we are going to discuss in the maxima and minima. Without remembering this one, it is not possible to find out the maxima and minima. And further, again, we need to understand what is the working rule to find the maxima and minima based upon this is the concept only. That is based upon this is the concept and previous that is a partial derivatives and also like other conditions. Here, the procedure to find the extreme values. That means the procedure to find out that is a maxima or minima. And what is the working rule here? That we are going to discuss now. Here, the function is f of x comma y. In that, according to first of all, we need to find out what is with respect to x and y. And second one, you find out what is a stationary point. The stationary points are calculating with the help of that equating that fx is equal to 0 and fy is equal to 0. And again, next one, we need to find out what is a r comma s comma t. As you know that we discussed just now, it is r is nothing but it is a second derivative x square, and s is nothing but with respect to x and y. And again, t is nothing but that is with respect to y square, that is also second order. And based upon this r, s, t, we find out at the stationary points. Whatever we got it, these are the stationary points. You need to find out what is the values are, that is r comma s comma t. This is the important to the steps we need to follow. One is finding the f p comma q, that is fx fy, and next one is the stationary points, and the third one is at the stationary points you need to find out r comma s comma t, that is the second order. And based upon this r comma s comma t, here we need to find out that is the structure of to finding that identification for the maximum or minimum. That means here that finding that rt minus s square at the stationary points. And again, for example, it is a conclusion, and again the resulting at the table based upon that conclusion also. Based upon the condition of rt minus s square, here how to identify what is the condition, that is a PQRST based upon that. For example, it is a resulting after calculating rt minus s square, it is greater than 0. That means if rt minus s square is greater than 0, as well as the r is also greater than 0, that means the function is said to be, it is a minimum value. The function is said to be, it is a minimum value. And again, rt minus s square is greater than 0 and r is less than 0. Then the function is said to be maximum. The function is said to be maximum value. And other one, if it is rt minus s square is less than 0, for example, then the function is a saddle point. The saddle point is nothing but it is neither the maximum nor minimum of the given functions. And further, rt minus s square is equal to 0. Then it is a further investigation, it is required. This is the conditions under that based upon the rt minus s square. This is the main working rule to find out. That means first we need to find out what is the PQ, that means first order derivatives, and second one is find the stationary points, and after that finding the values are r comma s comma t, and further we need to find out rt minus s square, and again we need to identify that what is the condition at a particular point, that is a stationary point. What is the condition? Rt minus s square greater than 0 and r is greater than 0. The function is said to be minima, and rt minus s square is greater than 0. The value is r is less than 0. The function is a maxima, and rt minus s square is less than 0. Then the function is a saddle point, and again the rt minus s square is equal to 0. It is a further investigation. It is required. These are the under the major working rule under based upon that finding the maxima minima. And last one, that is I think it is a similarly the procedure to find out other stationary points. At each stationary points we need to calculate same the result and conclusion the topic only. Like these are the conditions. And further, the last concept under this is the part B, that is model 3. It is a Lagrange's multipliers method. What is a Lagrange's multipliers method? The Lagrange's is nothing but it is a scientist name. Based upon the scientist to finding that maxima or minima. Here how to find out means by taking any that connected the two functions with the multipliers, that is assume that lambda. Based upon the lambda and again the given two functions, we need to find out the maxima and minima. Okay, and again here first this is the working rule. What is the working rule under the Lagrange's multipliers method? Here this method is applied. Here what are the major conditions, what are the some important to remember. This method is applied for finding the maxima or minima the given function which satisfied the given conditions. That means any function is attachment with another function, that is nothing but it is a constant. That what is a constant together the conditions. And again next one, the drawback of this method is that it gives no information about the nature of the stationary point directly, that is about the maxima or minima. That means the drawback of this the multipliers method, especially there is no information about the nature of the stationary point directly. That is not possible to find out the directly nature of the stationary point. And again, next one, it is a condition is, it is a, here unknown constant lambda is known as the Lagrange's multiplier. That means given the two functions connected with one multipliers, that multiplies it is nothing but lambda. That lambda is called as a Lagrange's multipliers. These are the three conditions. These are the three important points we need to remember under this the Lagrange's multipliers method. For example, the distance between these are also to remember, that is a one particular, that is a distance between the 2 points. We need to finding the solutions. This is the useful the formula. Here, what is a procedure? What is the procedure for finding the and maxima and minima? That means the given functions are like one is a f is a function and second one is a y is a function. We need to observe that properly. In that, while we are going to calculating here, what is a particular value is given, what is a particular value is not given. That means, for example, it is any particular function is given the value is nothing but that is like a pi, and again not given the value is nothing but f is a function. That while we are going to observing like logically easy to identify, easy to do the problems, what we are going to consider the f and also that pi. Based upon this, the f is a given function, and again f is like pi is a given some particular value of the given function, and f is not given any particular value. And again, based upon this one, construct a new function that is a capital F is nothing but it is a f is a function plus lambda into that is a pi of x comma y. And that means it is a not given the function is not given the value is considered f, and again the connected given the function value is a pi. With the help of that capital F is equal to f plus lambda into pi. And based upon that, we need to solve the three equations together. Fx is equal to 0, fy is equal to 0, fz is equal to 0. That is fi is equal to 0, fi is equal to 0, because this is the under the two variables only, and pi of x comma y is equal to 0. And find the stationary points x1 comma y1, and again it is finding the value of f of x comma y, the above stationary points, and again the conclusion, it is finding the maximum or minimum. While we are going to discuss that, easy to find out. And similarly, what we discussed up to here, the previous slide, these are the important topics we are going to remember that under this the model 3, and based upon this one only we need to discuss that clearly, that is a question bank. Without remembering that all these points, it is not possible to discuss the question bank. Okay, and anyhow, already we discussed in the previous lectures each and every topic wise we did given the clear lectures in the previous sessions, to finding the maximum minima and the Jacobian, and again the partial derivatives, and again the mean value theorem, Rolle's theorem, and Lagrange's theorem, and again the Cauchy's mean value theorem. Individually, all the topic wise we discussed clearly in the lecture wise, and today this is only the question bank. Based upon that, all the review it is required to understand the conditions. And again here also the model 3. This is the functions of several and single and several variable. And again here part A, in the previous sessions, model 1, model 2 question bank discussed properly, and again this is the model 3 question bank. And again here part A is same, here also the 10 questions. Part A is covering like that critical thinking question, part B is essay type question, 20 essay type question, and part C is 10 20 short type questions. Here first one, it is a summarize the conclusion of the Rolle's theorem for the function. Here the given function is given that f is a function, and again the interval is also clearly given that 1 comma 3, and based upon that we need to find out that is a Rolle's theorem, is it applicable or not, to find the solution if it is applicable. Here according to, we need to remember first condition and second condition and also third condition. That means f is a function, it is a closed interval a comma b. Is it continuous or not? It is clearly continuous. And again f is a derivable, that is fd is a derivable. The derivative is existed or not under the open interval a comma b. And again after that we need to check it, what is a f of a is equal to f of b. That means here a is nothing but, since here a is nothing but 1 and b is nothing but 1. Based upon that f of 1 and f of 3, if both are the values are same or not, and again based upon this one, then there exists f dash of c is equal to 0, then it is equal to c belongs to a comma b. We need to find out what is the value of whether it is satisfied or not. And again second one, it is same the function Rolle's theorem. We need to find out this is the given interval. Here we need to find out according to here also f is a function, it is a closed interval a comma b, roles as it is. And again second one is f is a function, it is a derivable a comma b. And again the third condition f of a is equal to f of b. Since here a is nothing but a and b is nothing but b. And we need to remember here, while we are going to calculate in this one, the function is nothing but, we easy to calculate that f of x is nothing but log of, it is x square plus ab minus log of x minus log of, that is a plus b. We need to split, easy to do the calculation, then find the solution. Then there exists c belongs to, that is a comma b, it is a c belongs to a comma b, such that it is a f dash of c is equal to 0. Then we need to find out what is the solution or not. And again here also utilize the Lagrange's mean value theorem. Here given the Lagrange's mean value theorem. While we are going to discuss the Lagrange's mean value theorem, we need to understand what is a f is a continuous in the closed interval a comma b, and second one is f is a derivable in the open interval a comma b. And again here f of a is equal to f of b, it is not required to find out. Then there exists to, that is f dash of c is equal to, that is f of b minus f of a by b minus a is a condition. Then there exists c belongs to, that is a comma b is a condition. And here given the conditions are a comma b is nothing but, it is a consider 0 comma 1, then it is a 0 is less than x is less than 1, that is 0 is less than c is less than 1. We find the solutions. Based upon this one, we need to find out according to the proper integration, we get the solution. It is clearly after that it is required to find out, that is sin inverse x. And again we need to remember, it is f of x is nothing but, the function is the sin inverse x, and f dash of x is nothing but, it is sin inverse x is nothing but 1 by root of 1 minus x square. We need to keep in our mind the derivative is also easy to get the solutions. And next one, solve that approximation of the value of this one. That means here also that LMV is nothing but, it is also Lagrange's mean value theorem. And here also that f is a, that is a continuous in the closed interval a comma b, and again f is also derivative in the a comma b, and again it is also, then there exists to c belongs to a comma b, such that it is also you need to find out, that is f dash of c is equal to f of b minus f of a by b minus a. And in this function, while we are going to discuss here, it is also nothing but f of x is nothing but, that is treated as f root of x. And again here also based upon this one, we need to assume that a is equal to something, that is a 243, and again b is nothing but 245, and based upon the nearest value we need to find out, then find the solutions. Then there exists c belongs to a comma b. And again next one, the Cauchy's mean value theorem. And moreover the functions are clearly given, the two functions here according to the Cauchy's mean value theorem. Here f comma z are both are the continuation a comma b, and again the second one, that f comma z are the both are the derivable in the open interval a comma b. Then there exists here, that is provided g dash of x is not equal to 0, such that it is f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Then there exists c belongs to, that is a comma b. We get the solutions. This is the, we need to verify the conditions according to by using the Lagrange's mean value theorem. And further it is u is equal to something and v is equal to something and w is equal to something. That means while we are going to observing the sixth one, that up to five problems are based upon, that is like mean value theorem, and again the sixth one is like Jacobian, that is based upon the partial derivatives. And again it is required to find out that u, that is nothing but ux, uy and uz, and v2, vx, vy and vz, wx, wy and wz. We need to find out what is the value of this one. First of all, we need to calculate what is a Jacobian, and based upon this one, after getting this one, you need to replace at 1 comma minus 1 comma 0. This is nothing but at x is equal to y is equal to z, we need to replace in the, after calculating in the Jacobian, that we need to replace, we get the solution of the sixth one, that is a Jacobian. And similarly here also identify whether the functions are the functionally dependent or not, and if functionally dependent, then find the relation between them. That means while we are going to observing this one, here it is a functionally dependent or not. If it is a functionally dependent, the functionally dependent means we need to find out what is the j of, that is u comma v that is a by that is x comma y. That is nothing but we need to find out what is the dou of u comma v by it is a dou of x comma y is equal to whether 0 or not. If it is 0, you find the solutions with respect to u and also v. And again after that, here while we are going to observing this one, v is nothing but according to inverse trigonometric function, tan inverse of it is x plus y by 1 minus xy is nothing but tan inverse of it is v is nothing but u. Therefore, it is a v is equal to tan inverse u is nothing but it is a tan inverse tan v is equal to u is the final solutions. That is the relation between means whatever we given the equation like that u comma v, and with the help of that we need to find out what is the relation between that. When we need to observe that properly, we can get some idea also. A rectangular box open at the top, volume is a 32 cubic finds, and again the dimensions of the required least meter it constructions. That means the rectangular box open at the top, volume. That rectangular box open value is nothing but it is v is nothing but it is xyz is equal to 32. That is v is nothing but the rectangular box open the volume is nothing but xyz is equal to that is a 32. Find the dimensions of the box required least metal its constructions. That means what is the surface means. That surface is nothing but it is a 2xy plus 2yz plus 2zx. But it is one side it is open is given. That means we need to assume that it is xy plus 2yz plus 2zx. Yes. And we are going to observing this one, it is clearly based upon the Lagrange's multipliers method. We need to follow that. Because of one function is given, that function is given is nothing but it is a given value is nothing but as per it is a Lagrange's multipliers, it is a pi. And again the unknown function value is given, that is nothing but f is a function. And based upon this one, it is a capital F is nothing but small a plus lambda into pi. That f is nothing but here xy plus 2yz plus 2zx plus the lambda is nothing but pi is a xyz minus 32 is a value. And based upon that, we need to find out what is like fx is equal to 0 and fi is equal to 0. Finding the values, we need to eliminate lambda and find the values, we get the final solution of the conditions. And after that, identify whether the following functions are the functionally dependent. Here also same like that. Is it the function j of u comma v by x comma y is equal to it is nothing but dou of u comma v by it is a dou of x comma y is equal to, we need to check it whether is it 0 or not. That is a functionally dependent. Is it 0 or not? If it is 0, the functionally dependent. It is not equal 0, it is not a functionally dependent. And based upon this one, after that, we need to find out what is the further relation. While we are going to observe in this one, it is clearly that is based upon the inverse trigonometric function. Here, while we are going to consider, it is also nothing but, let us assume that in that sin inverse u is nothing but x, and again it is not x. Sin inverse u is nothing but already x is given, therefore a, and again sin inverse v is nothing but it is a b. And from this, it is a sin a is equal to that is a u, and again sin b is nothing but it is a v. And based upon that, from the first equation x is nothing but u is nothing but it is a sin a, and again the root of 1 minus v square. Root of 1 minus v square is nothing but root of 1 minus sin square b. It is nothing but cos b. Plus it is also v. V is nothing but it is a sin b, and again it is a root of 1 minus u square is nothing but 1 a, and again it is nothing but cos a. That is sin a cos b. Sin a cos b is nothing but, as we know that is a sin of a plus b. And a, it is nothing but it is a sin inverse of it is a sin inverse u plus sin inverse v, and it is also nothing but clearly it is a sin inverse of it is a y. That means the final solution is x is equal to that is sin inverse y is a final solutions. That is a relation between the conditions. Easy to that depend upon the inverse trigonometric functions. We need to find the solutions and find the minimum values of the given function. That means whatever one is given that x square plus y square plus z square, and again xyz is equal to a cube. And we are going to observe in this one, two functions are given. In the two functions are given means what is a given particular value, what is a given not particular value. That means given particular value is treated as it is a pi, and not given the value is nothing but it is assumed that f. And based upon that, f is nothing but f plus that is a lambda pi, and f is nothing but xyz x square plus y square plus z square plus lambda into that pi is nothing but xyz minus aq. And based upon that, we need to find out what is the stationary points like that, eliminate lambda, and again that find the values are x comma y comma z. We need to replace in that particularly that is a given functions. These are the problems like under the critical thinking, that is a under this module 3, that is a part A. And again further we need to find out what is a part B, long answer questions. Like again here also show that the Rolle's theorem. The Rolle's theorem is nothing but here also the function is first condition, second condition, and third condition. F is a continuous interval a comma b, and again the open interval a comma b, and you need to find out what is f of a is equal to f of b. Then there exists to c belongs to a comma b such that is f dash of c is equal to 0. And here a is nothing but 0 and b is nothing but it is a pi, and f of x derivative. That means the product rule we need to find out and find the solutions. And again here that is a c belongs to that is a 0 comma pi is a clearly one of the solutions. And second one the Rolle's theorem, and again it is also given the functions, and it is also same the applicable according to the first one. The Lagrange's is nothing but based upon that first condition f is a continuous function, f is a continuous function in closed interval a comma b. Second function that is f is a that is open interval a comma b. And again the third condition, what is that? It is a then there exists to c belongs to a comma b such that it is a f dash of c is equal to f of b minus f of a by b minus a is the conditions. With the help of this one, we need to find out here a is 0 and b is 0. Then there exists c belongs to 0 comma 4 is it satisfied or not? That we need to show that, because of it is clearly asking to find out the show that the function is a Lagrange's mean value theorem. And further it is a same like the Lagrange's mean value theorem. It is also that is a first condition f is a continuous function closed interval a comma b, and second one f is a derivable in the open interval a comma b. Then there exists to c belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus a. But in this problem we need to assume that f is a function f of x is equal to, while we are going to observing in this all the conditions, it is a tan inverse x based upon. That means it is a tan inverse x is equal to. And according to f dash of x is nothing but this is a 1 by 1 plus x square. And again further find the solutions. A is equal to as it is the a and b is equal to b. And again after getting that, we need to show that this one and this one, at the time of this one we need to assume that after that verification of b minus a by like that, we need to assume that it is a is equal to that is a pi by 4, and again b is equal to nothing but that is a 4 by 3. And again in that also whatever we obtain the required the series, and in that we need to replace that a is equal to it is also pi by 4, and again b is nothing but it is a 2 is the value. And based upon that we need to verify the required solution of that whatever it is a first solution and also the second series. And next one, the problem is based upon that finding that value of c, but given that two functions, that is a Cauchy's mean value theorem. That means the first condition f comma g both are the continuous function, and again the second function that is f comma g both are the derivable functions, and again it is a open interval a comma b. And again the third condition, that is a g dash of x is not equal to 0 provided then there exists c belongs to a comma b such that it is a f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. And again here the c is lies in between, we need to show that it is a 3 comma 7 is a value or not. That is the final conclusion of this is the fifth problem. And similarly the Cauchy's mean value theorem is also same as the above fifth problem. We need to find out whether both are the continuous or not, differentiable in the open interval or not. Find solution. And again in here we need to find out the same the conditions according to the above one. We need to verify that c is belongs to 1 comma 2 or not based upon the conditions. But here the derivative is also we need to require to remember. And further it is a eighth one, the Rolle's theorem. the first condition, second condition, and the third condition. F is continuous in the closed interval a comma b, the derivable in the open interval a comma b, that is a f of a is equal to f of b. Then there exists c belongs to a comma b such that f dash of c is equal to 0. Find the solutions. It is clearly almost, it is also like like it is also belongs to, that is a Lagrange mean theorem is nothing but it is a problem is based upon the like fourth problem. It is like as a fourth problem. Find the solutions. And Lagrange's mean value theorem, like similarly we need to further 0, 4 only, like about 7th, 6th, 7th problem. 6th, 7th problem. We need to show that what is f is continuous in the open interval a, closed interval a comma b, and f is a derivable in the open interval a comma b, and again the conditions. Then there exists c belongs to a comma b such that it is f dash of c is equal to, that is f of b minus f of a by b minus a is the conditions. Is it satisfied or not? We need to check the conditions. Almost it is the find the values are c belongs to a comma 0 comma 4 is the one condition. And further it is if u comma b, like here also we need to prove that j into j dash is equal to 1. That is j is nothing but you need to find out dou of x comma y by dou of u comma v is equal to, we need to find out. And similarly that j dash is also nothing but we need to find out that j dash, is nothing but if possible we need to convert j dash is nothing but dou of u comma v by dou of x comma y. Find the solutions. And whatever we got it, these are the j and j dash automatically the reciprocal of the values. And again after that, again it is a problem is one problem, and again the second one is also, while we are going to observe in the second one, it is and according to that is a second one dou of x comma y comma z by dou of u comma v comma w. We need to find out it is minus 1 whole cube into, that is implicit formula. Why? Because it is a complicated given. It is a dou of, that is f1, f2 and f3 by dou of u comma v comma w by dou of f1 and f2 and f3 by dou of x comma y comma z. By using these values, then find the solution, we get the problem. According to this one, it is a implicit formula, you need to find out. Implicit formula. Find the value. And second one, this one based upon the dou of u comma v by dou of r comma theta. This is like as per the composite function. Here the given dependent is u comma v by, it is u comma v by dou of x comma y, and again dou of x comma y by dou of r comma theta. Here because of given the functions are u is a function of like x y, and again v is a function of x comma y, and again x is a function of r comma theta, and y is also a function of r comma theta. Based upon that, you need to find out according to one by one, like dou u by dou x and dou u by dou y and dou v by dou x and dou v by dou y, and again dou x by dou r, and again dou x dou x by dou theta, dou y by dou r and dou v by dou theta, and find the values. And it is also like according to dou of x comma y, you need to find out dou of r comma theta, and we get according to it is at the time of this one, it is clearly that is xr and again x theta, yr and also y theta. You need to find out. While coming to point, that is a dou of r comma theta by dou of x comma y, we need to assume that minus 1 whole square into the dou of f1 comma f2 by, that is dou of x comma y by, that is dou of f1 comma f2 by, that is dou of r comma theta. While we are going to do that according to the second one, we need to follow that according to, that is the implicit formula. Otherwise, we need to follow that by using the converting into in generally r comma theta in terms of x comma y, find the solutions. Here it is the implicit formula, you can find out, and again otherwise that is a first one we can find the solutions. Here f1 is nothing but f1 is a x minus e power r into, that is a secant theta is equal to 0, and f2 is a, that is y minus e power r into, that is a tan theta is equal to 0. Based upon this one, assume that we can find the solution. Easy to get the solution, that is implicit formula. And again the third one, next one, ux is equal like that x comma y comma z. It is also nothing but By composite formula, you need to assume dou of x comma y comma z by dou of u comma v comma w is equal to the three variables. We need to assume that minus 1 whole cube into the numerator, that is dou of f1 and f2 and f3 by dou of u comma v comma w, and similarly dou of f1 f2 f3 by dou of x comma y comma z. And here also, what is the f1 f2 f3? That f1 is nothing but f1 of ux minus yz is equal to 0, and f2 is nothing but vy minus zx is equal to 0, and f3 is nothing but wz minus xy is equal to 0. While we are going to assume that with the help of this one, is indicate. This is nothing but implicit formula we need to find out. That is implicit formula we need to find out. Implicit method. Implicit method, we need to find the solutions. We get the easy proper values. Make use of the Lagrange's multipliers method, and it is also clearly Lagrange's method of multipliers only. X plus y square is given subject to the condition ax plus by plus is equal to c. That means given value is not given value is nothing but assume that f, and given value is nothing but pi. With the help of that, capital F is nothing but f plus lambda pi. It is f is nothing but x plus y square plus, it is also x square y square plus lambda into pi is nothing but x plus by minus c is equal to 0. And find the solution by using the first order derivative for fx and fy. We find the solutions. And find that maximum value of the rectangular parallel pipe that can be placed in the sphere, the Lagrange's method. Volume of the rectangular parallel pipe. Parallel pipe is nothing but that is a 2x into, that is 2y into 2z. Volume is nothing but this one. It is nothing but 8xyz. And again, that can be sphere. The sphere is nothing but it is a consider. It is a sphere is nothing but it is a x square plus y square plus z square is the value. Here based upon is equal to 1. Sphere is nothing but it is 1. And based upon that, it is also same like that f, and again it is also nothing but pi. And together f is nothing but f plus lambda pi. It is nothing but 8xyz plus it is a x square plus y square plus z square minus 1, and find the solutions. These are the particular we need to recall that according to all the formulas while we are going to discuss. That is what is the sphere equation, what is like rectangular parallel pipe, and again what is the volume of the condition, then find the solutions. And next one, find the volume of the rectangular parallel pipe. That is also nothing but volume is nothing but the rectangular parallel pipe is a 2x into 2y into 2z, same like the previously. That is a 8xyz. Ellipsoid is given, but whereas in the previous problem that is a cube, that is a sphere, but it is a ellipsoid, and it is nothing but ellipsoid is nothing but x square by a square plus y square by b square plus z square by c square is equal to 1. It is not given. It is assumed that f, and it is assumed that it is a pi. That is f is nothing but f plus lambda pi is nothing but 8xyz plus lambda into assume that x square by a square plus y square by b square plus z square by c square minus 1, and find the solutions with respect to fx, fy, y, fz, and again eliminate lambda, and again find out that x comma y comma z, and again replace in the volume of the rectangle parallel. Next one, sin x into sin y into sin of xy, the condition is given like that. And we need to assume that it is also u, and again based upon that p, and also q, and again r comma s comma t. And we need to remember any problem is given under the trigonometric almost like what is that? It is a pi by 3 comma pi by 3 is a stationary point. We need to assume that is a r minus pi by 3 comma minus pi by 3, and again here, and again 0 comma pi by 3, and again here pi by 3 comma like 0, and again like many number of stationary points are obtained, but here remember these are the stationary points are very quick satisfied. These are pi by 3 comma pi by 3. And at these stationary points, we need to replace in the given function. We get the maximum value of the given function. U is a function. And similarly, second one, it is also same like the conditions, maxima or minima. And here also, while we are going to finding that p comma q comma r comma s comma t, by solving this one, it is clearly we obtain that it is also pi by 3 comma pi by 3 is a, we need to remember these are the stationary points. But other values are also there, but these are the remember the stationary points. These stationary points we need to replace in the maximum value of the given function. We get the solutions. And find the points in the plane that is the nearest the origin. Here also given that 3x plus 2y plus z is minus 12 is equal to 0. Near is the origin. Near is the origin is nothing but x comma y comma z. That is origin is 0 comma 0 comma 0. That means pq square is equal to, that is x square plus y square plus z square. And here it is considered pi and it is considered f. Therefore, capital F is nothing but small a plus lambda into pi. It is f is a, that is x square plus y square plus z square plus lambda into, that is a 3x plus 2y plus z minus 12 is a value. And find the solution by eliminating lambda. And again, after eliminate lambda, you find that x comma y comma z. And again, by using that x comma y comma z, we need to replace in that whatever the nearest to the origin, we get the solutions. That they are asking to find out only the points only. That means we need to find out that x comma y comma z as the values. And next one is the coming to point. That is the last one. It is a short answer questions. Here Rolle's theorem, it is applicable for any function. How Rolle's theorem means, that is the first one, and again second one, and again the third one. It is nothing but f is a continuous in the closed interval a comma b. It is a derivable in the open interval a comma b, and f of a is equal to f of b. Then there exists to c belongs to a comma b such that, that is f dash of c is equal to f dash of c is equal to 0 is the conditions. Then there exists to c belongs to 0, f dash of c is the conditions. How Lagrange's mean value theorem? Same, the first one and second one is same. F is a closed interval a comma b and it is a derivable on the open interval a comma b. Then there exists to c belongs to a comma b such that, that is a f dash of c is equal to f of b minus f of a by b minus a is the conditions. And next one, Cauchy's mean value theorem, like first condition, second condition, the third condition. F comma z are, that is a closed interval a comma b. It is both are open interval a comma b. G dash of x is not equal to 0. Then there exists to c belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by z of b minus z of a. Next, explain the Rolle's theorem geometrically. That means same like according to first one, second one, and also third one. We need to find out according to based upon that geometrically. It is a like continuation any points of the conditions. We need to find out according to the conditions. We need to follow the conditions. Or otherwise, it is 0 and x and y and again a and again b. That is f of a and f of b. That is the conditions. Tangent to the conditions. And other terminology also you can define the continuous. And similarly, geometrically, the Lagrange geometrically, same the first condition and second conditions. It is a closed interval a comma b, and it is a open interval a comma b. It is a f of dash of c is equal to f of b minus f of a by b minus c. Then there exists c belongs to a comma b such that the conditions. And based upon this one, geometrically, the condition is 0 and x and y. Geometrically, it is a not condition is satisfied because of it is a condition is it is a like conditions. That means it is a tangent, it is okay, but is a and b it is not equal to f of a. Therefore, it is f of a is not equal to f of b. Like condition, it is a not the same the condition according to that a comma b is a geometrical. Yeah, illustrate the example continuation the value which does not hold the conditions. That means mean value theorem. That f of x is the function, it is a f of a simple example, it is a minus 1 comma 1. It is at x is equal to the function is a not continuous because of it is a discontinuous function. Discontinuous function. Make use of the Lagrange's mean value theorem that to find the value of c. Same, that f is a continuous and again the derivable open interval. The third condition, then there exists to c belongs to a comma b such that it is a f dash of c is equal to f of b minus f of a by b minus a. We need to find out the c belongs to is like in between 1 comma e is a value. Here e is nothing but lies in between 2 comma 3 is a value. And similarly, why the Lagrange theorem means does not hold means it is a not continuation at 2 by 3 minus 1 is nothing but derivative, it is not existed. Derivable not exist. Not exist at 0 value. Derivative not exist. And again, this is the region, identify the region increasing. The function is also using the region increasing, no problem. F dash of x is the throughout an interval mean value theorem that show that the condition. It is also no problem. Here, dou of u comma v by dou of x comma y, ux, uy, vx, vy. And again, we need to find out this one, and after that, here find the value of dou of x comma y, dou of x comma ux. We need to find out dou of x comma y by dou of u comma v is equal to xu, xv, yu, yv. Otherwise, or implicit formula. Implicit formula. We need to find that. Find the stationary points. That means here we need to find out what is the p comma q. P is equal to 0 and q is equal to 0. You find the solutions. And z dash is nothing but dou of u comma v by dou of x comma y. It is minus 1 whole square of, that is dou of f1 comma f2 by dou of x comma y by dou of f1 f2 by dou of u comma v. Find the solutions. Or otherwise, j into j dash is equal to 1. The j dash is nothing but 1 by j. Otherwise, that is dou of x comma y by dou of u comma v. That is our choice by using the implicit formula, otherwise directly by using the formula. And it is also like j into j dash is equal to 1. That is j dash is equal to 1 by j. Or the dou of x comma y comma z by dou of u comma v comma w is equal to minus 1 over q by the dou of f1, f2, f3 by the dou of u comma v comma w by dou of f1, f2, f3 by dou of x comma y comma z. That is our choice. As we know that according to the properties of the Jacobian, we need to follow the Jacobian property. Otherwise, by using the implicit formula also, we can find the solutions. Because of here, the dependent variables are x, y, z, but the independent variables are, it is a u comma v comma w. But the given functions are u, v, w are the dependent, and independent variables are x comma y comma z. And next one is also, that is like xu and xv, yu, yv. You find the solution. And second, next is also the j is equal to, it is nothing but xr, x theta, yr, y theta. Find the solutions. We get the properly direct without any facing problem, we can get the solutions. And next one, j dash. J dash is nothing but 1 by j. We need to find out what is the j value here. That is j is nothing but xr, x theta, yr, y theta. And after getting this one, you can replace in that 1 by j is the value. And find the Jacobian. The Jacobian is nothing but j is equal to, that is xu, xv, yu, yv. We get properly. And j is also here also, that is ux, uy, vx, vy. We find the solution. And finally, that here also given that Jacobian, it is a u is a dependent variable ux, vy, and vx, vy. And these are the problems clearly able to understand according to based upon the what we covered in the beginning. That is like formulas under the part A and part B. That is mean value theorem, and also the several variable like according to partial derivatives, Jacobian independence, and also maximum or Lagrange's multipliers. If you understand the theoretical like concept and formulas, then only easy to survive this question bank. That what we discussed today class. In previous sessions we discussed that model 1, model 2, and this is the model 3. And again in further the next sessions we will go to discuss that is a model 4. That is a question bank that is covered like Fourier series model 4. In that we will discuss the depth wise, that is a Fourier series integration related to the concept only. I hope everybody understand this is the model 3 is also based upon the partial derivatives like concept and again the derivative, that is a mean value theorem. If any doubts and again required, give me the reply in the link only. Thank you. One.
Like, share and subscribe. Hit the bell icon for more updates.